will be interpreting functions with set theory. Now, it is worth making a distinction between a function and its description. The function is the abstract mathematical object that in some way exists, whether or not anyone ever talks about it. But when we do want to talk about the function, we need a way to describe it. A particular function can be described in multiple ways. Some calculus textbooks talk about the rule of 4, that every function can be described in 4 ways. Algebraically, a formula. Numerically, a table. Graphically, or in words. In discrete math, we can still use any of these ways to describe functions, but we can also be more specific since we are primarily concerned with functions that have the natural numbers or a finite subset of the natural numbers as their domain. Describing a function graphically usually means drawing the graph of the function, plotting the points on the plane. We can do this and we might get a graph like the following function. Let's say we have f, which has a domain 1, 2, 3, and a codomain 1, 2, 3. And this would be the graph of that function. Let's say we send 1 to 2, 2 to 1, and 3 to 3. That right there is the graph of my function. All right, so it would be absolutely wrong to connect the dots or to try to fit them to some curve. There are only 3 elements in the domain. A curve would mean that the domain contains an entire interval of real numbers. Here's another way to represent this same function. We might have 1, 2, 3. Yeah, there's our domain. Here's our codomain. And we might represent this function with arrows. 1 goes to 2, 2 goes to 1, and 3 goes to 3. This shows that the function f sends 1 to 2, 2 to 1, and 3 to 3. Just follow the arrows. The arrow diagram used to define the function here can be very helpful in visualizing functions. We will often be working with functions with finite domains, so this kind of picture is often more useful than a traditional graph of a function. Note that for finite domains, finding an algebraic formula that gives the output for any input is often impossible. Of course, we could use a piecewise defined function like f of x equals 2 if x equals 1, 1 if x equals 2, 3 if x equals 3. This describes exactly the same function, but we can all agree it's a ridiculous way of doing so, since we will so often use functions with small domains and codomains. Let's adopt some notation to describe them. All we need is some clear way of denoting the image of each element in the domain. In fact, writing a table of values would work perfectly. We might say that we have a table here where we have our inputs here and our outputs on the second row. And we have 1, 2, 3 as our inputs, and the outputs would be 2, 1, and 3 respectively. So these are all different ways of writing the same function, and my preference is the table, specifically in discrete math. In calculus, a lot of people like to use graphs because they're nice and continuous, or maybe it's slightly discontinuous. But yeah, discrete math tables work really nicely. Anyways, thanks everyone, and I'll see you in the next video.